We have now made it possible to create our card using drag and drop. In most web apps, the card is immediately stored on the server using a server-side technology such as ASP.NET MVC. Since that is not the focus of this course, we are going to take a slightly different approach. We are going to store the card locally. This way, when the user leaves the site and later on returns, the contents of the cart isn't gone and he can continue shopping. And for this, we'll use another new feature in HTML5, web storage. Before we look at web storage, let's take a look at what we used to have in terms of client-side storage options before HTML5. Well, the story is quite thin. The only option we had in HTML was cookies. I assume most of you are familiar with the concept of these small text-based files which are stored by your browser on the local disk. And since they're plain text and are stored in plain sight on the local disk, they're not secure, so it's out of the question to put any sensitive data in there. Their size is also quite limited. A cookie cannot be larger than 4 kilobytes, and per domain we are limited to 20 cookies. On top of that, with all the recent privacy issues, many people turn cookies off, which will then cripple your site's experience. In all, cookies were an okay solution in the 90s, but the world has evolved. We have other needs now. So what do we need in terms of storage for building great web applications then? We definitely need more space. A limit of 4K is not going to cut it. We also need the option of real storage on the client. What I mean by that is that we are in need of more capable data storage alternatives and ways to work with the stored data. Also, the data should be persistent on the client and should certainly not be deleted when the user closes the browser. And unlike cookies, the data should not be sent over the wire with every request. As you can see, the needs are very different from what cookies can offer us. With HTML5, another new API is introduced, namely web storage, also referred to as local storage or DOM storage. As the name implies, web storage will allow our web applications to store data on the client in a persistent way and in a much better way than what we could achieve with just using cookies. Firstly, web storage has an API, meaning that we have methods to add and remove data. This already fulfills the requirement to have real data storage from the browser. The data is stored in key value pairs, which we can query. The storage is entirely local, so the data is local on the device and remains there. This also means the data isn't being transferred with every request. A local storage object can be created per domain, which is somewhat similar to what we had with cookies. And local storage is supported in almost the same way in major browsers. Most browsers give us 5 megabytes per domain for local storage. Some browsers give us 10, but there seems to be a consensus around 5 megabytes. Web storage is implemented in two different objects, local storage and session storage. Now, what is the difference between these two? Data stored in local storage is persistent even after closing the browser. It is not tied to just one tab or browser window. It is shared between tabs and browser windows. One instance of local storage is created per domain. Session storage, on the other hand, will be deleted after closing the browser window or tab. So the storage is local, but only persistent as long as the user keeps the window or tab open. It is thus more temporary of nature. Also, a session storage instance is linked to a tab or browser window. If you have multiple tabs open with the same site loaded inside, each tab or window will have its own instance of session storage. Let's see how we can work with web storage. As mentioned, it's a JavaScript API, so we can only interact with both the session and local storage through code. In the code you see here, we are first checking if the storage is supported by the current browser. We do so by checking if the browser recognizes the storage object. If that is the case, we are using the local storage JavaScript object and use its setItem method to store a value locally, using a key, in this case the word coffee. Afterwards, we are retrieving the value by invoking the getItem method on the local storage object. Now, what else is supported in the API for web storage? Notice that the API is the same for both local storage and session storage. We have the setItem and getItem methods, which we already saw being used in the previous slide. There's also a remove item, which accepts a key and will then remove the item from storage if found. The clear method will clear all the stored items, and using the length property, we can see how many items have been stored already. The storage object also supports an event called storage. This event will be fired when data is being changed. We can register for this event to be notified about changes being made to the local or session storage. In the sample code you see here, we are attaching a callback named logMyStorageEvents to the storage event. The parameter is of type storageEvent and exposes a number of interesting properties. Key contains the changed key, old value contains the value being replaced with the new value. In the following demo, we are going to save the contents of the card locally using the local storage options we just saw. The previous demo was finished with the shopping cart supporting drag and drop, but you saw that on refresh, the entire shopping cart contents was gone. And we're going to fix that by adding support for the local storage also in the shopping cart. We're going to continue working with that same JavaScript file. So remember that we had the add D&D handlers function. The first thing I'm going to do is I'm going to create a constructor function for the cart object. And inside the cart, I'm going to create basically an array for the coffees property, which is going to contain all the coffees which were added using drag and drop. And I'm going to persist those using local storage. Next, I'm also going to create a coffee object, again using a constructor in JavaScript. So there we go. So now I have a coffee which has two properties, coffee ID and price. This doesn't do anything yet. We're going to use that in just a second. Next, I'm going to create a variable current cart. I'm going to set that to null for now. Now this current cart is going to contain the actual shopping cart's contents that is coming from local storage. First, I'm going to check if I already have something stored in local storage for this page. What I'm going to do is I'm going to ask local storage, check if we have an item with ID cart. I'm going to try to parse that and I'm going to store the result in current cart. And if current cart doesn't exist yet, I'm going to initialize an empty cart with a function called createEmptyCart. And let's first create that function, createEmptyCart. I'm going to put it here at the bottom. I'm going to, most importantly, create in my local storage an item with ID cart, and I'm going to set that to the stringification, the JSON stringification basically, of that new cart object that I just created. And then I'm going to set current cart, my variable current cart, to the parsing of the cart item that I'm getting from local storage. At this point, I either have an already existing shopping cart in local storage, or I have an empty, just initialized shopping cart as well. Next, I'm going to synchronize my UI, and I'm going to do that with a function called updateShoppingCartUI. I'm going to call that function. Now I, of course, have to implement that function. Let's put it again here at the bottom. What I'm going to do in this function is first set the inner HTML of my shopping cart, so that was my div UL, to empty. For each item, for each coffee basically, that I can find in the array inside my current cart object, I'm going to execute this JavaScript. I'm going to again initialize an li. I'm going to set its inner HTML, and I'm going to append it to the shopping cart, which was that UL. That's basically what we already did earlier. So now my shopping cart is basically in sync with the contents of the local storage. Now I also have to make sure that when somebody drops a coffee onto my shopping cart, it gets added to my local storage. To support this, I'm going to add onto my current cart a function named addCoffee. And inside this function, I'm going to add the coffee to the array of coffees. And also I'm going to override what is currently stored in local storage with ID cart with the stringification of current cart. Now this function is now created, but it doesn't get called yet. When do I have to call it? When somebody drops a coffee onto the shopping cart. In the drop, we had the call to this add coffee to shopping cart. I'm going to change that function. I'm going to remove the current contents. This is now the new functionality. First, I'm going to get hold of the data price attribute again, and I'm going to store that in a variable price. I'm also going to create a new coffee instance, passing in the ID as well as that price. Then I'm going to call my addCoffee function, passing in that function. And if you look back at what this did, this will add the coffee to the array and also override the local storage. So now we have safely stored my data in local storage. And finally, I'm also going to update the UI to reflect the change. If everything goes well, we should now be able to see that upon refresh, the shopping cart remains intact. Let's run it. Let's go to our coffees page. I'm going to add a coffee here and one more. I'm going to refresh the page. And as you can see, the shopping cart now stays intact. I've saved it locally, so upon return to my page, the coffees will still be in the shopping cart. And this, of course, greatly improves the shopping experience for the customer. Let's go back to the slides.